All right, so today, guys, want you all to, you can pause the tape and write down all of these definitions right now. Today we are talking about transformations of linear functions. And so take a minute and just write this, then we'll talk about it. All right, so today we're talking about transformations. You've hopefully written all these down. So the first definition that we're looking at is something called a parent function. This is the most basic of functions. The next one we're talking about is called a family of functions. This is where certain functions, they appear alike. They have similar characteristics. Like a linear function. One linear function might look like another linear function. Or one parabola might look like another parabola. They're in the same family. Okay? Transformation is a movement. It's a change. So how is the equation, what in the equation is affecting the parent function to move on the coordinate plane? Movements that we have are horizontal shifts, which is a right and left. And we get that by doing something to the input. Okay? Vertical shifts are up and down, and we achieve this change by doing something to the output. The reflection is, like, let's say I have something that looks like this. This would be the reflection. If it's this way, this would be the reflection over the same point. Okay? It's the mirror image. And then we've got some words called horizontal shrink and stretch and a vertical shrink and stretch. And we'll learn that in a separate lesson. All right, so let's talk about parent functions. So these are the big four parent functions. We've got the first one. You should be sketching these designs as I'm doing it. The first one we call a linear function. Oops. The first one we are calling a linear function. The second one we are calling a quadratic function. We see that whenever x is squared. Okay? This one is always looking like y equals x. The linear function is y equals x. The quadratic function is y equals x squared. The squared is what we call the quadratic. Notice the design of the quadratic function. What kind of picture does it make? Yes?
More like a parabola.
A parabola, or in kid words, we would say like a U. A quadratic function is like a U. The one below that has x for the exponent is called an exponential function. Okay? And then the last one, can anybody guess what it is? Christian? Absolute value function. Okay? Questions? Oh, look what I did. I wrote it wrong. Exponential. I-A-L. It's y equals anything to the x power. So somebody asked me today, what's the difference between this and this? Well, you will notice that in the exponent is not an x. Here, the exponent is an x. So in a quadratic function, the exponent is always a 2. Is that making sense? Theo, did I answer your question?
Yeah.
Yeah.
What's the difference between y equals 2 to the x power and y equals 3 to the x power or 4 to the x power?
They'll make the same shape. Okay? You look at on the x-axis, it will get closer and closer to the x-axis, but never really touch it. Okay, but that is like towards the end of the school year. Okay? So let's just go with the parent functions because this is a very difficult lesson right now.
So if you zoom in, you'll see the difference.
Yes. Okay? All right, can I erase this? Pause if you need to. All right, so I'm moving on. Here's something else I'd like you to take notes on. Now, whenever we talk about these, you will notice whenever we talk about functions, we talk about these items. Here you've got the family that they belong to. Then we have the rule, which is like the equation. We've got what they look like as a graph. And they always ask us to compare the domain and range. Okay? So on a constant, you should be writing this as we're going. On a constant, I want you to write this all down. On a constant function, tell me about the domain. Is the width, remember our domain is our width. Is the width limited on a constant function? Yes.
No.
No, it's not. It goes on and on horizontally forever. So that's why we're saying all real numbers. What about the range? What is the range here for the constant function? What is the height of the range? That's what we're really asking, yes.
It's doesn't scale.
Well, they're telling us it's going through 1. So if it says the f of x equals 1, that's like saying y equals 1. It's going through 1 on the y-axis. It doesn't go any higher or any lower than 1. So my range is y equals 1. Okay? Linear functions. Okay? When my line is just going through the origin, tell me about the domain. Is the domain limited? Is the width limited? It goes on and on forever, so we say all real numbers for the domain. What about the height of this line? What about the height? How about Olivia? On the second one that says linear, tell me about the range. Is the height limited, or can it go on and on forever height? So we say all real numbers. Y equals all real numbers, or range R equals all real numbers. Absolute value is where it changes. Is the width limited on absolute value? Is it?
No.
No, it goes on and on forever in both directions, of the width. And so we would say all real numbers. But what about the range? How is this different? Yes.
It starts at 0.
Right. The values of y, of any point on this graph will never be less than or equal to 0 because it's resting at the origin. Okay? So it will never be less than or equal. That's why we say y is greater than or equal to 0. Now the parabola. Tell me about the domain, please. The parabola. Yes?
The domain, like absolute value, is on and on. Any real number.
All real numbers. But Hayden, what about the range here?
Oh no, you were just saying how it will never be equal to 0.
No. It will be less than or equal to 0. 0 is y can be a 0. Because this is, what point is this there?
0, 0.
Right, and we know that this is going to be like 1 comma 1. But y will never be less than 0. Okay? Y can be, because remember when we're asking for the range, it's what is y allowed to be. Y can be, y is greater than or equal to 0. Does that make sense? Did I say it wrong? Okay. Julia.
But that's only for this certain parabola and absolute value. They're not all.
Correct. These are for parent functions. Now, these are the parent functions. When the parent function for, this is the most basic of all, absolute value, starts at the origin. Okay? Notice it starts at the origin. Notice a linear goes right through the origin. And we will notice that the parabola parent function, y equals x squared, goes right through the origin. Okay? All right, can I move on? Guys, you got to write faster because I've got a lot. All right, so there are four main things that we can do to transform a line or a function. We can add something to the input. This also means subtract because I can add a negative. We can add to the output. You should be writing and going. We can multiply to the input or multiply to the output. Write quick. So now we're going to actually do some transformations. So again, just sketch it. It's not using a ruler. So when we say the f of x equals y, this is just equals x. This is the same thing as saying y equals x, right? So the first thing we're going to talk about, which is the most difficult, is a horizontal shift. Moving it left and right. Horizontal is left and right, h units. So what I mean is, you see how I'm moving the line? See those arrows? I'm moving it to the right. Okay? Here's how it looks in the equation. And where h is greater than 0, it moves to the right. But when h is less than 0, it moves to the left. Now let's talk about what this all means. So if I have let's make a table of the parent function. Okay? Making a table. Okay, what am I putting on my table for the parent function? What do I put in my table? We're on the red line, which is the parent function. Theo?
0,
0,
0.
0. What else?
1.
Christian? 1, 1. What else? Charlie?
2, 2.
2, 2. Can we assume this goes on and on?
Yes.
Okay. So now when you see it inside the parentheses, it means the input is what's changing. It's the input when it's inside the parentheses. Now, here's what's happening. When I have a horizontal shift, so let's say I had the f of x equals, or not equals, I'm going to change it to the f of x minus 2, okay? When I have that minus in there, which direction am I moving? Yep.
To the left.
To the left. Why?
Because you are now decreasing.
Okay, we need to be careful here. Because remember, here is the formula right here. Say x minus, okay? The only thing I'm inputting is in this little box right here. Right here. Did I put a positive or a negative too?
Negative.
I did not.
Positive.
In the box, I only put a positive 2. The negative is part of the formula. So do you see how I put? It's very tricky. I input a positive 2. So since it is a positive 2, it's moving, when h, it's going to move to the right. But how does it look to you? It looks like I'm doing this. It looks like we move in the negative direction. But really, this and this are part of the formula. The 2 is actually positive. Does that make sense? So that's why I'm moving it over to the right 2 units. Does that make sense? Now, if I had something like this, the f of x, and all of a sudden it became, remember the formula is minus, what am I putting in this box to make it move to the right? No, to the left. Matthew.
Put like -2.
I'm going to put a -2. Are you with me? Now, what you're going to see is this. I'm going to simplify it. The f of x, what's negative times negative? The way I got that positive is really because I input a negative. The formula has a negative, and then I input another negative. So you're going to see, when you see plus, you're going in the negative direction. When you see plus, you're going in the negative direction. When you see minus, you're going in the positive direction. Yes, I understand. No, I don't. Yes.
So would this only be for the parent functions for that?
Let me get to the rest of it because I don't think you understand what's happening yet. So let's just look at the trend and everything. So the f of x is the parent function. When you see something happening inside that parentheses, there's a transformation happening. If it reads x minus a number, we're moving it in the positive direction because it's really a positive number that's been input. If it says x plus, it's really a negative number, so it's going in the negative direction. Are you clear? Okay, now, you noticed I said, oh, let me go back. So if I were changing my input and I really wanted to move it, so let's say I'm using this one. Do you guys see it? This right here? So we said because it's inside, it affects the input. So if I wanted to write the transformation, I would say 0 plus 2 plus 2 plus 2. Does that make sense? And the new table would be, it'd be 2, 0, 3, 1, 4, 2. Are you guys with me? Those would be the points of the new line that I'm doing. Okay? Yeah.
So the new line, you graph it and that's the transformation?
Yes. Now, you don't have to make the table every time because you can count over. If you can tell from the equation which way it goes, you should be able to just count points, which we're going to do. Okay. Vertical shift is up and down. This is when you see f of x, something's happening outside of the parenthesis. We do something to the output. So I'm shifting, and this is very straightforward. If we see plus a number, we rise it up. If we see minus a number, we bring it down. Okay? So this is f of x, right? And remember, f of x equals x. This is the same thing as saying y equals x, right? And this might be this is like the f of x equals the f of x plus 2.
Why is it h?
Don't worry about it. Okay? Because it's height, or like height units, okay? Yes, Olivia. All right, are there any questions here? Yeah.
Why is it less than or greater than 0?
Because when k, right here, we're taking it at face value. When it's a number bigger than 0, it moves up. So if it's 1, 1.5, 2, 3, moving it up on the y-axis. If it's minus, we just take it for face value.
So the line...
It's not tricky like horizontal.
Okay, so...
Whereas there's that embedded negative.
Yeah, so the line that you start with without transformation always goes to the origin?
Yes. Okay, now I'm so far behind. Okay, I'm going to, the reflections, I'm going to change. We multiply by we'll do this after because I want to start you with homework, okay? So I'm going to put it on pause, and then I'll do the reflections for the recording. Okay, so now when I do a reflection across the y-axis, you will notice we've got our parent function, the f of x. And so when we're reflecting across the y-axis, we actually do something to the input. We're multiplying it by -1, and we're multiplying the inputs by -1, and so that's allowing it to reflect. We're multiplying your x's by -1, and it's reflecting over the y-axis. And so that means it makes it symmetrical with the y-axis, across the y-axis. If I'm reflecting over the x-axis, I'm going to multiply my y's, my outputs, the entire f of x. I'm going to multiply the entire f of x, not inside the parentheses, but the entire quantity, because remember, the f of x is really your y equals x. So here what we're doing is we're really multiplying all your outputs by -1 there, and that's going to allow us to reflect it over the x-axis. Okay? And it's symmetric with the x-axis. Over the x-axis, symmetric with the x-axis. All right, so now let's just say, let me make a table and let's look at what that's going to be looking like here. So let's make it red. So my original one, we know that if it's the f of x, it's going to be 0, 0, 1, 1, 2, 2, 3, 3. Now, if all I'm doing, here's the x, here's the f of x. So to make the transformation, I'm really multiplying all of my f of x's by that -1. So now I'm going to get the new one will be, here's my x, here's my new f of x. A lot of times they'll rename it like the g of x for the second function. So I'm still using 0, 1, 2, 3, but my new points are going to be 0, -1, -2, -3, right? 0, -1, 0, -2, 1, 1, -1, 2, -2, and you see that's where the new points are. Is that making sense? And the same thing goes here. When we reflect over the y-axis, we're really manipulating the x. Right? We're really okay? If I were to make that table here, when I reflect over the y-axis, I really affect my x. Here's my x, here's my f of x. And so 0, 0, 1, 1, 2, 2, that's the original red line. And then my new one, this time, I'm multiplying only the input. That's what it means when it's inside by -1. So now my new x is going to become 0, -1, -2, and this is still 0, 1, and 2. So you've got 0, 0. We have -1, 1. You see how it reflects it naturally. So a couple different ways to do that. And that is our lesson. I kind of got people started on the homework. So I'm going to take a picture and actually, let's go to the end. Pause it. Okay, so starting your homework tonight. First thing you're going to do is you are going to take, this is a parent function, and you will notice that this parent function okay, so the recording stopped recording, and I'm not exactly sure when that happened. So, I think when I started the homework. So the very first thing we're going to do is copy the parent function. Not sure if it was the next one. All right, so here's the homework for tonight. So the very first thing you're going to do is, this is what we call a parent function, and you're going to grab that and put it, it's going to be, do it exactly, you're going to copy exactly what's there onto every single graph for the parent function. So it's 1, 2 units over, 1 down. Okay, so I'm going to go 2 units to the right and 1 down. I'm not sure how much of this keeps turning off on me. I'm just doing my parent function. I'm going 1, 1. I'm going 1 over. And then I'm noticing the other one was 2, 2. 2 across, 2 up. And I connect those points. I call that the f of x. Now, since I'm shifting, since it's outside of the parentheses, I'm going to shift it vertically up 2 units. Each point is going to be up 2 units. And I just connect those points. And so this becomes the f of x plus 2. And then we describe what we are doing. So here we had a vertical shift, 2 units up. Okay? If you look at the next one, what's happening to the f of x? It seems to be affecting just the input inside. So that is going to be a horizontal shift because there's a positive. To really get that positive, remember, there's already an embedded negative in the formula. So to make that become a positive, my input value is what I'm adding here for the 2 is really a negative 2. But I first do my parent function. And now, here's my f of x. I'm going to go 2 units because it's inside, it's horizontal, and we're moving 2 units to the left. When I see a plus sign, I move to the left in the negative direction. 1, 2, 1, 2. 1, 2, 1, 2. Okay? And that becomes the f of x plus 2. Questions? I guess you can't ask questions, can you? That's silly. And this is a horizontal shift 2 units to the left. Now you'll notice on this last one, we've got both. It's a combination. I'm going to start from my parent function, and every point I'm going to go 2 units up, 1, 2, and then 2 units to the left. 1, 2. That would be my new point for this one here. Okay? Okay, so you're going to do that and explain every time. Now, when I go to the next picture, let's look at the back side of it. Since it's being affected, the first question I'm going to ask is, oh, I didn't mean to do that. Let's go back. Okay, so the first question they're asking is, it's a shift vertically. So what's my y-intercept currently with the current f of x equation? The y-intercept would be a 2. So what they're asking you to do is create a new one, shift it vertically, the whole line. So if I'm shifting it vertically, I add that 6 to the 2, and my new y-intercept would be 8. Okay? Now horizontally, I think the best thing to do for 9 and 10 is to just graph it and then count over 5 units. Okay? Or up. Or horizontally plus 3 units. Number 11 and 12 are based on this table here. Now remember when we said it was outside the parentheses, you're doing this to your output. So this affects this. We're still using the same input, but that output. And here, when it's inside the parentheses, it affects the input, right? I'm using this diagram here too, but this is going to change because we're having to deal with this, the plus 3 to the input. Okay? And then see what you can do for 13 and 14. All right. Sorry if there's some repeat. You can fast forward through it. I don't know, that stopped recording.